So here we want to find out whether summation xi is greater than k or less than k, right? So we need to simplify these terms, right? Here we can divide by this term, right? It is p1 1 minus p naught by 1 minus p1 into p naught power summation xi is greater than k2. K2 means k1. What is k2 here? K2 equal to k1 into this term, that is 1 minus p naught divided by 1 minus p1, the reciprocal of this term, right? Then here we need to find out summation log xi is greater than k or less than k, right? So we can take a log on both sides. Take log on both sides, that is, which implies summation xi log into this term, that is p1 into 1 minus p naught 1 minus p1 into p naught, right, which is greater than k3. What is k3 then? K3 equal to log k2, right? So here in the first case, that is case 1 is p1 is greater than p naught, right? So here we want to find out whether summation xi is greater than k or less than k. But it here in this term, we also have an additional term, right? That is a log p1 into 1 minus p naught divided by 1 minus p1 into p naught, right? So we have to, so we want to divide by this term, right? For that, first we have to know whether it is a positive or negative term, right? So here we know that in the first case p1 is greater than p naught, right? Then p1 divided by p naught is greater than 1, right? And also we want to know whether 1 minus p naught divided by 1 minus p1 is greater than 1 or less than 1, right? So here it's given that p1 is greater than p naught, right? Then what is minus p1 and minus p naught? If p1 is greater than p naught, then minus p1 is less than minus p naught, right? So then what is 1 minus, if it is smaller than these, right, then 1 minus p1 is greater than 1 minus p naught, right? So then which implies 1 minus p1 divided by 1 minus p naught is greater than 1, right? So here here p1 divided by p naught is p1 divided by p naught is greater than 1. Also 1 minus p naught 1 minus p1 divided by 1 minus p naught is also greater than 1, right? So it implies that term is log, this term is see what is the value when log 1 and what is the value when log 0.9, what is the value when log 1.1? When log value is log some value is less than 1, then it takes values negatives, right? This is less than 0. When log of some value is greater than 1, then which is the value is greater than 0, that is a positive number. Here it's a negative number, right? So then become here this term is greater than 1, right? Then log this term is greater than 0 is a positive number. Then we will divide, then summation xi here, if divided by these term, then the sign is remains same, right? That is summation I 1 to n greater than k3 divided by log p1 into 1 minus p naught divided by p naught 1 minus p1 is it's greater than, right? Because this is a positive number, positive value. Then the sign remains same, right? Then what is the rejection region then? Then rejection region equal to summation xi greater than k, right? So here we need to find obtain the we need to write the most powerful test, right? Test for testing h0 versus h1. That is a test function for testing h0 versus h1 is phi of summation I1 to n xi equal to 1 if summation xi is greater than k, right? So this is a one discrete distribution problem, right? So it takes all values, right? So this test function becomes non-randomized test. What is the non-randomized test? The critical function takes values between 1 and 0, right? 0 and 1. So this is for the discrete distribution case we can write non-randomized test. That is the critical values take the values between the critical function takes the values between 0 and 1, right? Then we take one value, that is gamma. Take the values, that is gamma if summation xi equal to k, okay, 0 otherwise. So here we need to find out what is the value of k and what is the value of gamma, right? In a continuous case only we have to find out what is the value of k, right? But in discrete case we want to find out what is the value for gamma and also k. Here k and gamma determined by the size condition, that is expectation of phi of summation xi equal to alpha, right? Which implies what is the value, what is the expectation of phi of summation xi? 1 into probability of summation xi greater than k plus gamma into probability of summation xi equal to k plus 0, right? Equal to alpha. This 1 into probability of summation xi greater than k plus gamma into probability of summation xi equal to k plus 0 equal to alpha, right? So let we take a y equal to summation xi, okay, which implies probability of y is greater than k plus gamma probability of y equal to k equal to alpha. So here we need to find out the values of k and also gamma, right? So we can use a cumulative density function for that. So for that in order to write cumulative density function, how to notate cumulative density function of a random variable x, that is a probability of x is less than equal to x, right? So this is the form of cumulative density, right? So we want to make this term as a cumulative density function, that is here probability of y size, right? That is probability under is not probability y greater than k plus gamma p naught y equal to k equal to alpha, right? So we make that term as cumulative density function term, that is 1 minus probability of y greater than k plus gamma probability of y equal to k equal to 1 minus alpha. Here 1 minus, take, which implies we can write these terms as 1 minus p naught probability of y greater than k minus, here minus, right? So then we come into multiply, then it's minus, right? Minus gamma p naught y equal to k equal to 1 minus alpha. Then we can write these terms as 1 minus probability of y greater than k as probability of y less than equal to k, right? Minus gamma probability of y equal to k is equal to 1 minus alpha, right? Which implies we can write these terms as the probability of y less than k minus 1. Here y is less than equal to k, right? So that contains the values of y less than equal to k, means y equal to k plus it also contains y less than k values, k minus 1 values, right? Then we can write probability of y less than k minus 1 plus probability of y equal to k. This term we can write probability of y less than k less than equal to k as probability of y less than k minus 1 plus probability of y equal to k, right? Minus gamma probability of y equal to k equal to 1 minus alpha. So we can write these terms as probability of y less than k minus 1 plus, here probability of y equal to k, also here probability of y equal to k, right? Then we can take the common term. We can write the common terms, that is probability of y equal to k into 1 minus gamma, right? Equal to 1 minus alpha. Equation, here equation star. So from these we want to find out what is the value of here less than equal to k, right? We want to find out the value of what is the value of k and also what is the value for gamma, right? For that we can use these star equation. What is these term? Probability of y less than equal to k minus 1, which implies that it's PDF of k minus 1, right? Sorry, CDF, right? Cumulative density function, which implies probability of y less than equal to k minus 1, which is here probability of y less than equal to k minus 1 is a CDF, right? It is plus this term equal to 1 minus alpha, right? Then you can take these term, then that is probability of y less than equal to k minus 1 is if you take this only term, one term, then which is less than or equal to 1 minus alpha, right? Here equal to 1 minus alpha, then probability of y less than equal to k minus 1 is less than equal to 1 minus alpha, right? So using these we want to find out the value of k and also value of gamma. So for that we have to construct cumulative density function table. For that we want to use y values, that is y equal to 0 to 1, 2, 3, so on so on k minus 1 also k value, right? It is next we want to write the density value, right? This probability of y equal to y. What is the probability of y here? Y equal to y, that is the density of y. We know that x follows Bernoulli with the parameter p, right? Then summation xi follows. Here we know that y equal to summation xi, right? Summation xi that equal to y, which follows binomial with n comma p. right? That is a probability of y equal to n cy p naught power y 1 minus p naught power n minus y, right, in CDF. So here we need to find out what is the CDF value, right? This value. So first we want to obtain the value of y equal to 0. Then what is the density? That is same as CDF, right? Then next we want to obtain the value of density when y equal to 1, right? Then we want to obtain CDF, that is a cumulative density, right? We want to add the values here, right? The density value corresponding to this. Then this is probability of y equal to 0. Then same, right? This probability of y equal to 0. Then this is probability of y equal to 1. Then the cumulative is probability of y is less than equal to 1, right? Which means it contains the values summation of these two density, right? So similarly, like here, probability of the density of y equal to k minus 1, right? Then here, probability of y less than equal to k minus 1, right? Then here, probability of y equal to k, right? So cumulative density exceeds 1 minus alpha. Here cumulative density exceed 1 minus alpha at the first time, then the corresponding value of y is k. Okay, that is a cumulative probability exceeds 1 minus alpha at the first time, then the corresponding value of y equal to k. Okay, then from the equation star, here we obtained k value, right? The cumulative probability exceeds 1 minus alpha at the first time, then the corresponding value of y is k, right? Then we have to find out what is the value of gamma, right? From star equation, what is gamma? The star equation is a probability of y less than equal to k minus 1 plus probability of y equal to k, 1 minus gamma equal to 1 minus alpha, right? So here we want to obtain the what is the value of k, right? Then rearranging the term, then the gamma equal to 1 minus alpha minus probability of y less than equal to k minus 1 divided by this term, right? That is a p naught y equal to k. Here 1 minus alpha, right? Then this implies gamma equal to 1 minus this term, right? After simplifying, after rewriting the star equation, we can get gamma value, right? So this is the gamma value of this problem. So next, so here we obtained value of k and also value of gamma, right? And then this is the most powerful test for testing H0 versus H1 in the Bernoulli case, in the distribution case. Next, we will go in for the second case, that is a case 2. Case there is a P1 is less than P0. Okay, if P1 is less than P0, then